Greetings, Chem 2 students. Mr. Keister here with you again today. This is the video for Monday, November 23rd, 2020, which is our scheduled 66th day of school for the fall semester. Always keep in mind, though, that the dates could change for a variety of reasons, but the lessons and the order that those lessons are presented will remain the same regardless. So let's take a look at our do-nows and see what the schedule is for today. So today we're going to begin Unit 6.1. Which is regarding chemical quantities. And in particular, we're going to spend a lot of time talking about the mole, all right? Not the kind that digs up my yard, but the mole in chemistry, which is probably the most important mathematical concept in this entire subject matter, because we can do so many things, so many different calculations using the mole, all right? Oh, by the way, here are my moles, my mascots, all right? This one here is Avogadro, all right? You'll see why. Appropriate name. This is Avogadro. Notice he's got his lab coat on. Actually, they both have their lab coats on, so they're getting ready to get serious and get down to business. And this little guy here is Adam, and Adam's a whole lot smaller. Come on, man. Is there any chuckling out there whatsoever? Atom, A-T-O-M, smaller. Well, it's Monday. You know, I always try for a little Monday humor, and sometimes it works and sometimes it fails miserably. But anyway, Avogadro, Adam, my mascots. A student of mine got those for me many, many years ago, and I've kept them ever since. Love those guys. Anyway. So our Unit 6.1 notes packet, you're picking up today, page 87. And our assignment, the mole and Avogadro's number, Avogadro, I just mentioned that name, is page 88. Your homework for today was to complete the organic compounds number 3 assignment, which we finished this past Friday. Turn that in. It's due now. Of course, if you're here in school, that should already be on my desk. If you are at home, then you need to be submitting that to me electronically at your regularly scheduled class period time, all right? So don't be late with that, folks. Of course, you can check your answers with the answer key first. If you're here in school, they're up on the board in the back of the room. If you are at home, they will be posted on the answer keys page in Canvas. Both of those, of course, by 7 a.m. this morning or earlier. Reminder, do not forget that your Unit 5 review packet is due tomorrow at the beginning of class. And again, no answer key available for that one since there is no test over this particular mini unit. So it's going to count for significantly more points than a regular review would. We've gone through this before. You should know the drill by now. I would make sure that I'm checking my answers again with my classmates to see if everybody did the things the same. And also remember that even though we didn't have an exam over this unit, you are responsible for knowing this information. All of this organic nomenclature stuff going to appear on the next several exams and also on your final, all right, which is not very far away. Semester 1 is drawing to a close rather quickly. And one last reminder on this review, before you turn it in, make sure that your organic drawings are properly done. In other words, no sloppiness, all right? I've talked about that before. Some of your assignments up to date have been somewhat sloppy. And by sloppy, I mean that when you're adding on your functional group attachments, that you're not attaching carbon to carbon, all right? Make sure you do. Make sure you do. Functional group carbons attached to a carbon atom on the main chain, not to hydrogens or somewhere in between. So make sure your drawings are more accurate, all right? I will take points off for those if they are sloppy. All right. That's due tomorrow, beginning of the period, so don't forget. So today we're going to begin Unit 6.1 on the mole. The homework assignment you picked up today will be due tomorrow. And I put a note here on the bottom of the do nows. This unit involves quite a bit of math, all right? And so there we are again over there. Never to leave, all right? Make sure that you are showing all work, all right? All work that is required for each particular assignment. Make sure you label things properly. Make sure you round the correct sig figs and all that good stuff. All right, so don't forget about that. All right, well, let's pull up the notes and let's get started on Unit 6.1, shall we? Okay. All right, so in chemistry, the mole is the SI unit that is used as a basis of measurement for any chemical substance. Just like we use the meter to measure length, the SI unit for time is the second, the SI unit for energy is the joule, and so forth. The SI unit for an amount of a substance or any chemical element or compound is the mole. All right. Chemical substances can be quantified using the mole in three different ways. Number one, which we're going to study today, is through the representative particle, which is the smallest individual unit of a particular substance. Now, depending on what type of substance it is, could be a monatomic element, could be a diatomic element, could be a compound, ionic or molecular. Then we have a particular base unit for that. Could be the atom, could be the molecule, could be the formula unit. We can also quantify the mole using via mass, in which case we use grams, all right, standard unit of mass in chemistry. And we can also quantify a chemical substance via the mole for volume in regard to gases, all right, volume in regard to gases. And this would be in liters, and this is only for gases at certain standard conditions. If you remember the term STP, which we've talked about before, standard temperature and pressure, that's what we're going to here. So today we're going to look at quantifying the mole in terms of representative particles, all right? Chemical substances have the following type of representative particle or their smallest individual unit. First, all the monatomic elements. So remember, this is 111 out of the 118 elements on the periodic table. Their smallest unit is the atom, all right? The atom. That would be also then their representative particle. For the 7 diatomic elements, remember Hankel fiber? Hydrogen, oxygen, nitrogen, chlorine, fluorine, iodine, and bromine. For those 7 elements, remember, they are diatomic, meaning 2 atoms are bonded together covalently to form one molecule. All right. So the formula unit for the 7 diatomic, I shouldn't say the formula unit, the base particle for the 7 diatomic elements is the molecule. It is also the representative particle for a molecular compound, which remember is bonded covalently between nonmetals with each other or nonmetals with hydrogen. All right. So all molecular compounds, their representative particle is also the molecule. And then for ionic compounds, which of course are formed from ionic bonding between a metal and a nonmetal, or between a metal and a multiple nonmetals, such as a polyatomic ion, their representative particle is called the formula unit. I've mentioned this before. A lot of times we refer to them as molecules just out of simplicity, but in reality, molecules do not contain fully charged particles. Right? Polar molecules are partially charged, but fully charged, no. All right, those are ionic compounds, and so we want to make a distinction here in regards to that in terms of representative particles. So for ionic compounds, their base particle, their representative particle, is called the formula unit, all right, which again contains charged ions, okay? All right. Now, no matter what type of chemical substance it is, any of those 4, all right, there are 6.02 times 10 to the 23rd representative particles in 1 mole of that substance, and that is called Avogadro's number, all right, Avogadro's number, named for Amadeo Avogadro, who actually theorized this number. He did work in trying to determine this number when he was working with gases. We talked about Avogadro's law before. And he actually didn't live long enough to verify that number was correct, although it was verified after his death. and so his determination of that number was found to be correct. And then in doing that, the number was named in his honor. Okay, so let's get to the next page here. So in a monatomic element, there are 6.02 times 10 to the 23rd, or Avogadro's number of atoms in 1 mole. Atoms, all right. In a diatomic element or a molecular compound, there are 6.02 times 10 to the 23rd, or Avogadro's number of molecules in 1 mole. All right. In an ionic compound, there are 6.02 times 10 to the 23rd, or Avogadro's number of formula units in 1 mole. All right. So depending on the type of substance, that representative particle is different. All right. But the number of those particles in 1 mole is the same. All right. The same. These equalities can be used as conversion factors in dimensional analysis. So we're going to return to that. Or if you use proportional reasoning, which you could, I prefer a dimensional analysis, especially in multi-step problems, which we could have here. So again, that's my preference, and I think you'll see that method of conversion used almost exclusively in your college classes. So we can use this factor, all right, involving representative particles in moles to solve mathematical problems involving that. So we got some examples to look at here. So let me move the screen up a little bit. All right, so in the first one here, it wants to know how many moles of the element magnesium are there in 9.31 times 10 to the 21st atoms. All right, so we are going, this is our information that's given. We are going to set up a conversion, dimensional analysis, starting with that piece of information. Again, we place that over 1. All right, so we have 9.31 times 10 to the 21st atoms of magnesium. We want to make sure we label that number completely. All right, now we're going to convert this to moles. And the conversion then is the fact that there are Avogadro's number of atoms in 1 mole. All right, 1 mole. So we have atoms up here, so we're going to have atoms of magnesium down here and moles of magnesium up top. So the atoms cancel. And as we just said, there are 6.02 times 10 to the 23rd atoms of magnesium in 1 mole. All right, there's Avogadro's number of particles in 1 mole. So, and that's the only steps we need. All right, so we're going to take our given number of atoms and divide it by Avogadro's number. Now, let's take a quick stop here and talk about sig figs. All right, we have been given 3 sig figs in our beginning information, and that is what we are going to utilize as our final answer. Now, Avogadro's number here is expressed to 3 sig figs as well, but I wanted to let you know that in these calculations involving the mole, that constants are not determined by sig figs. Let's make a little note out here. Sig figs not determined by constants. Unless, of course, the only figure you have to work with is a constant. And then we have to make an exception to that rule, but that's not the case here. That has happened to us before, though, but not here. So constants can have varying numbers of sig figs. Now, in this case, Avogadro's number is expressed to 3 sig figs, but I've seen it expressed to 4. I've seen it expressed to more than that. So, and other constants, the same. Kind of depends on the reference you pull the constant from. So since the sig figs there can be all over the place, depending on where you look them up, they are not normally utilized in determining sig figs of an answer. We go back to the original measurement, okay, which we've talked about that before too, in other situations. So that is going to again apply here. So whatever your original measurement or measurements give you in regard to sig figs, we are going to use the least number of sig figs based on those measurements. In this case, there's only one, so 3 sig figs it is. So when we divide those two numbers, we get 0.0155 moles of magnesium. Again, that is expressed to 3 sig figs. Or if you want to put it scientific, of course, it'd be 1.55 times 10 to the negative 2 moles of magnesium. Either way, 3 sig figs though it is. All right, next one. How many molecules of carbon dioxide are contained in 0.25 moles? Okay, so in the first problem, we was talking about atoms, and this one is talking about molecules. Well, here we're talking about a monatomic element, magnesium, which the representative particle for a monatomic element is an atom, but CO2 is a molecular compound formed from covalent bonding, and so the representative particle there is the molecule. However, the number of particles in 1 mole is the same regardless. That's Avogadro's number. So now we're going to start with 0.25 moles of CO2, put that over 1. And as we just said, in 1 mole of anything, there are 6.02 times 10 to the 23rd particles. So in 1 mole of CO2, which we're going to now put on the bottom so that those units cancel in our dimensional analysis, there are 6.02 times 10 to the 23rd molecules of CO2. And if you want to abbreviate molecules, M-O-L-E-C, that is fine. That way you don't have to write the whole thing out. Oh, and while I'm thinking about it, moles. So is there an abbreviation for the unit mole? Yeah, well, there is. So normally I write it out if it's mole or moles, all right? Either 4 or 5 letters, depending. The abbreviation for mole is mole, M-O-L, which removes 1 letter from the actual unit, or if it's more than 1, it removes 2 letters from the actual unit. I've never done that. You'll see that though in a lot of literature, and that's fine. So if you want to, save yourself an unbelievable amount of time by eliminating the E from mole and just using MOL, or eliminating the ES from moles and just using MOL, that's perfectly okay with me. I rarely do that. I will on occasion, but normally I just don't. But you certainly can. All right. But again, for molecules, MOLEC. Make sure you got the C on there. Otherwise, it looks like mole. All right. So make sure you do that. So in any case, we're going to take 0.25 times Avogadro's number, and our original information now only has 2 sig figs, and so that's what we're running with. And that comes out to be 1.5 times 10 to the 23rd molecules of CO2. Again, make sure that's 2 sig figs. Make sure that you label completely, all right? Don't just write molecules. Don't just write CO2. It's molecules of CO2, okay? Third one, how many formula units of calcium chloride are there in 2.33 moles? Formula units. Okay, this calcium chloride is an ionic compound, all right? Remember, it contains charged particles, ions. In this case, our unit, our representative particle, our base unit is the formula unit, all right? So we have 2.33 moles of calcium chloride. Ooh, what's the formula for calcium chloride? Oh, well, let's think back. Calcium's in 2A plus 2. Chloride is the negative ion of chlorine, which is in 7A, which has a charge of -1. So with plus 2 and -1, I'm going to need 2 chlorides. CaCl2 is the correct formula. Well, I sure hope you can remember that. All right, definitely need to know how to write a formula. That skill is never going to go away starting now. All right, well, starting before now. Okay, so we want to convert that to formula units. Well, how many formula units are in a mole? Same number of atoms that are in a mole, or same number of molecules that are in a mole. It's Avogadro's number. So that's going to go down in the bottom. So in 1 mole, or I should say 1 mole is going to go down in the bottom of CaCl2. We have 6.02 times 10 to the 23rd formula units of calcium chloride. Okay, formula units. How should we abbreviate that? Because that's kind of a long word. Formula, 2 words actually. Formula units. Well, I don't really care how you do it. I use FORM-UN. I've used FUN or funds. All right. I only have one request. All right. Please don't abbreviate it FU. All right. That, when I see kids use that as a abbreviated form of formula unit, I'm thinking, okay, are they doing that because it's the fewest number of letters, or are they doing that because they're trying to send me some subliminal message that they don't care for this lesson, or they don't care for me in general? I'd like to believe that's not the case, but believe me, when I'm grading 100 and some papers at night, and I get to a problem and I just keep seeing FU, FU, FU. You get what I mean, all right? I know I'm hearing some chuckling out there. Happens every year. So my only request is, please don't use FU as a abbreviation for formula unit, okay? I would like to keep my self-esteem at a reasonable level, so I would appreciate it if you didn't do that, all right? So if you want to go small, we can go fun. How's that? FUN. That I can live with, all right? So anyway, like I said, so I'll go with that. Formula units of CaCl2. Avogadro's number in 1 mole. So again, the moles cancel, and we're given 2.33 moles, so that's the number of sig figs we're going to run off of for our answer, which is 3. And that then comes out to 1.40 times 10 to the 24th formula units of calcium chloride. All right. Now, we have an additional question here. How many chloride ions are there in the above sample of calcium chloride? It says C handout here, but I don't have a handout, so I think that's from years ago, so we can kind of forget about that. But let's talk about formula unit. All right, so I said a formula unit is the representative particle of a of an ionic compound, of which calcium chloride is one. And it contains ions, all right? So a formula unit contains charged ions. So let's look at calcium chloride. We said its formula is CaCl2, all right? Well, why is it CaCl2? Well, because we said calcium has a charge of +2, and yet chloride has a charge of -1 as an ion. And so in this formula unit, I should say in 1 formula unit of calcium chloride, there is 1 calcium ion, and there are how many? There are 2 chloride ions. All right? That's important to know. All right? So, and if you remember, well, why is it 1-to-2 ratio? Well, because calcium wants to lose its 2 valence electrons. A chlorine atom only wants to gain 1 electron, so when they combine bond ionically, they do so in a 1-to-2 ratio. So we can use this right here. In this case, we're asked about chloride ions as a conversion factor. So we're going to take our answer up here, 1.40 times 10 to the 24th formula units of calcium chloride. Put that over 1, and now we know that in 1 formula unit, we'll put that down at the bottom so they cancel out, there are 2 chloride ions. All right, 2. For every formula unit, there are 2 chloride ions in that formula unit. And so this is just double. So there are 2.80 times 10 to the 24th chloride ions in this 2.33 moles of calcium chloride. So now, had we been asked that initially, we would have done this all in one step. We'd have started with our 2.33 moles, used Avogadro's number to convert it to moles, and then in the third step, use our other conversion factor, the fact that there are two chloride ions in one formula unit of calcium chloride. We would have used that as our third conversion factor and done this calculation all lickety-split in one process. All right. Here I wanted to show you where this conversion factor comes from the fact that in one formula unit of calcium chloride, there are two chloride ions. Now, if it had asked how many calcium ions are there in the above sample, well, there's one calcium ion in one formula unit, so that answer would have still been 1.40 times 10 to the 24th calcium ions. There are double the number of chloride ions in this quantity of calcium chloride as there are calcium ions, again, because of that 1 to 2 ratio. All right? So, I think that's it for today. So you got an assignment over this. It's due tomorrow. Again, I caution you to make sure that in your calculations that you are showing all the work required, just like we did here. Make sure you label your conversion factors completely. Make sure you can't show that you are canceling them out. That's all part of the process, all right? And then again, make sure that you are rounding correctly based on what we said regarding that. So I think that's it for today. So until next time, this is Mr. Keister signing off. Stay safe, everyone. Take care. Stay focused and keep working hard. And I'll catch you next time. So long, guys.